I mentioned in the previous lecture that a variable defined inside a function is not accessible outside of it, and that's because there are basically two components of your program now after you've defined functions, and you'll say that this whole part is a function definition, and this whole part is your main program. So a variable defined inside the scope, inside this function definition, basically is not available outside of it. And I said that it's because these functions sort of have their own bubbles. A formal definition of that bubble is called a scope. The keyword is scope, and a formal definition is a set of programs or program statements, so basically some code over which a variable exists. So I can say that the parameter defined amount exists only within the scope of this candy function, and it will not be available to the main program. Similarly, the cost variable, I've defined it inside the function, and it is not accessible outside of it. So the scope of the cost variable is within the definition of the function. So I'll say the scope of the cost function, of the cost variable, sorry, is within the definition of candy function. So this sort of makes things a little bit easier to understand that if I were to define a variable inside one of my functions and also use the same variable name outside here, I might not be able to access it. So I shouldn't be able to run line 10, which basically says print, let's say, amount. So because the scope of amount is only within the candy function definition, it does not exist outside. It does not exist in my main program. Okay, so a cool way to figure out what the scope of each variable in my main program and in my function definition is, and also how Python basically copes with these different scopes, we're going to draw some diagrams here, and we'll start off with a main namespace. So think of namespace as just a space where all the variables and functions defined in the main program exist. And then we will also go over the memory, so how values are stored in memory. So Python objects in memory. And I'm going to make this one too. Whoops. Make a box like this. So we know that everything in Python is an object. So whenever I store a variable with some value, I'm going to write the name of the variable here and the value over here. I'm going to put an arrow to point out what the value of a variable is. Okay, so what's going to happen is that when Python runs this program, the first time it executes, it's going to create a main namespace. So it doesn't always just exist. It comes into life when I run this program. And what happens when I run code line by line, right? I go line by line, is that at line 1, it realizes that there exists a function called candy. So Python at this point will acknowledge that a function candy exists. And the way you describe that in the namespace is you say candy is a function that exists. So I can use it now. So anything here can be used inside this main program. Next, the lines 2 through 5 are basically the code that will be executed when this function is called. And then at line 6, I'm defining a variable called KitKat. It is in the main program. So I'm going to say KitKat is a thing. And it has the value 5. So in memory, an integer 5, an immutable integer 5 is stored, and it sort of makes an arrow and says, okay, KitKat now points to 5. Next at line 7, I'm saying that k leftover, so KitKat leftover, is going to be candy function with KitKat passed as parameter. And what this function is basically doing is it takes an amount, it calculates the cost by multiplying the amount by 2, it reduces the amount by 1, it prints the cost and returns the reduced amount, okay? So when I call this function, when I call the candy function at line 7, it is now going to create its namespace. So they're not just created beforehand, only when I call a function will its namespace be created. So I'm going to say candy namespace. And the idea is the same. You're going to list out all the variables that are going to be defined inside this candy. So the scope, within the scope of the candy function. So at line 7, I am calling this function. So I'm going to jump to line 1. And the first thing you'll notice is that a variable amount is defined. So I'm going to say there is a variable called amount. And what's the value of amount? Well, we know that positional arguments are a thing. So whatever the value of candy was is going to be the value of amount. So if candy was 5, amount is going to be 5. And the way you describe that in this diagram is that whatever the value of KitKat was is going to be the value of amount. And in that case, I will say that officially, or roughly speaking, amount points to the value of KitKat in memory. Right? That's what I'm doing. I'm saying that whatever the value of KitKat was in memory, amount is now going to point to that too. All right. After that, at line 2, you're defining a variable cost, and it is going to be the value of amount times 2. Okay. Now this is still within the scope of this function, so I'm going to put it here, not here. So I'm going to say cost, and it has the value of amount times 2, which is just going to be 5 times 2, which is going to be 10. So cost now points to 10 here. Okay. Next, at line 3, you're saying take the value of amount and reduce it by 1. So amount equals the current value of amount minus 1. So if amount is 5, you subtract 1 and store it back in amount. Now, here's where a important thing happens. Amount here is pointing to whatever the value of KitKat was, but if inside a function I change the value of amount, it's sort of going to make it's going to redefine it basically in memory. So it's going to do something like this. It is now actually going to point to amount minus 1, which is 4, and this little arrow goes away. So again, let me go back. We know that amount is an integer, right, based on what the value is, and we know that integers are immutable. So I cannot just mutate an amount, a value, an integer basically, without having to redefine it. So when I redefine what amount is within the scope of this function, it will not change this 5 to 4. Instead, it will say, okay, I will redefine it. So it does something like this. It goes and says, I'm going to now make a new value in memory and point to that, which is going to be amount minus 1, which is going to be 4. And so this happens. So it is no longer pointing to what KitKat was. Instead, because integers are immutable, you've redefined what amount is going to be. Okay, next, in this line, you're going to print cost. So whatever the value of cost is going to get printed into terminal, and you're going to get like 10 printed out on your computer. And then at the very next line, you're saying return amount, return whatever amount is. Awesome. So this whole thing should evaluate to whatever amount was, which is 4, and it is going to be stored in k leftover. And the way you show that in this diagram is you say k leftover, and notice that I have now moved back to the main namespace because I'm defining the main program here. And so it is now going to point to whatever was being returned by the amount, which is going to be 4, right? Okay, now once this execution of my program stops happening, once I stop executing my program, this namespace goes away. That's why it's dynamic. So the next time I'm going to call this function, it won't know that I had actually called it previously. And so what's going to happen is that this whole thing is basically going to go away. And any variable that was defined, sort of like here, so these arrows are going to go away. And any variable that was defined and is currently no longer being pointed to also gets lost. The 4 here stays because now it is being stored in k leftover. But after line 7 gets executed, the namespace of my candy function and all of its variables and all the values that we're pointing to, they all just disappear. So you're left with all of this. And that's why that's the reason that I cannot just do after line 7, I cannot do, oh, can I print the value of cost here? I can't because it no longer exists. Also, it no longer exists within the main namespace. I had never defined it in the first place. So that's why those things will give you an error. Okay, let's power on. Next, what I'm doing is I'm saying that Mars is 15. So I've defined a new variable, and it is Mars, and it is currently pointing to the value 15, right? And then I'm saying that I have defined a new variable m leftover, and it is going to point to, or it's going to be equals to, whatever the candy function returns with the value Mars in it. All right, so I'm calling this function, which means I need to make its namespace again. So the namespace is created. I will go ahead and draw this box, and then the whole game starts again. I'm saying that candy defines a variable called amount. Okay, that's the first thing you see at line 1. And it is going to point to whatever the value of Mars is. So it's going to point to something like this. Okay, then I'm saying that cost is equals to amount times 2. So I'm going to define a variable cost, and there's space here. So I'm going to say it's 15 times 2, which is let's say, which is going to be 30, and cost points here. Okay, and then I'm saying take the value of amount, reduce it by 1, and store it back into amount. Now, because amount is immutable, it is not going to do something like this. It's not going to say, oh, I'm going to make this 14. You might think that might happen, but what's that going to do once this function stops working? It's going to also change the value of Mars here to 14, which is something think about it. That's wrong, right? I'm not changing the value of Mars here. I'm changing the value of amount. So it shouldn't affect what happens to Mars here that's defined outside the scope of this function. So instead, what Python does, it says, okay, I am no longer going to point to this 15 here. I'm no longer going to point to this 15 here. Instead, I'm going to reduce the amount by 1, which is going to be 14, and I'm going to store it in a new space in memory. Okay, then you're going to print cost. which is going to be 30. So you get 10 printed, and then you get 30 printed, and then you're going to return amount. And let's make some more space here. You're going to make amount. You're going to return amount, which means that I'm going to need a little bit more space here. And I'm going to say that, okay, M leftover is a new variable. M leftover is a new variable, which is going to take the value of whatever is returned by Candy with the Mars part passed in, and that's just going to be the current amount value, which is 14 here. Once that happens, once this line stops executing, I've evaluated my function, it returned 14, I've stored it in M leftover, it is now, Python is now going to remove this namespace. It's going to say, okay, you have done your job, but you are no longer needed. And anything, so all the arrows also go away, and anything that currently is not pointed to by my namespace, my main namespace, goes away too. So that 30 went away, but this 14 is currently being stored by M leftover, so it stays. So at the end of the execution of this entire program, where I defined a function Candy that takes in a parameter amount, it calculates the cost, it reduces the amount by 1, and then it prints the cost and returns the amount, and I'm using it basically twice. At the end of this whole execution, after line 9, let's say, this is what's left in your namespace and in your memory. You'll have 4 variables: KitKat with a value of 5, K leftover with a value of 4, Mars with a value of 15, and M leftover with a value of 14. Now, once this program ends, once this program basically ends, when your execution stops of the entire program, the main namespace also goes away. So this too will sort of go away. And so all the arrows go away, and all of this information is basically lost. So that's why you're not able to say, oh, I'm going to run my program once, and I'm going to run my program again, and I'm going to hope that the same variable sort of exists. That's not going to be the case. So the memory stays, but all the variables now are going to be lost. So that's a basic idea of how scope comes into play and how values are passed basically around using through parameters and return values. And this whole diagram, this whole process is called parameter passing. It's a lot more theoretical, so you won't be able to basically write code for it basically, but it's a very important thing to know, how parameter passing happens in Python, and it sort of uses the idea of scope of functions and main programs. And the way I defined it, that if I were to redefine what amount is, it's no longer going to point to what KitKat was or what Mars was. It's only because amount, KitKat, and Mars are immutable variables. Let's look at an example of what happens when they are mutable. Let's now see how scope and parameter passing come to be when I'm using a mutable variable everywhere. So I have a function called extender. It will take presumably a list and a value, and it's going to append that value to that list. And outside, so again, this is my function definition. And here I'm defining my main program. And within my main program, I've defined a list called a list. It has the values 1, 2, 3, and I'm printing it. Then I'm defining a variable at line 5, num, with the value 4, and then I'm calling the function with the list here and that number, and then I'm going to print the list at the very end. Okay, the idea here is to see again how mutable parameters, when you're passing them, behave compared to immutable. We know that if it was an immutable variable is being passed, and if I change the value, it's going to redefine them. But let's see how the namespace sort of looks like playing with lists here. So I'm going to say this is my main namespace, and we're also going to define our Python objects in memory. And I'm just going to make small boxes here. Hopefully they'll fit. And let's see what happens when I run this code. So at line 1, Python will acknowledge there exists a function called extender, and it takes 2 parameters and is doing things. So in my namespace, I will add extender, which means that I can use this function anywhere in my main program. That's why I can use it. And then I'm going to do, at line 3, I'm going to define a list. Okay, so a list. And it is currently pointing to here in memory, and it is pointing to a list. Right, 1, 2, and 3. Fairly simple, we know that. And then, let's say if this was my terminal, I am saying print a list, so I'm going to print 1, 2, 3 here. Fairly simple. At line 5, I'm defining a variable num with the value 4. It is still in main, so it's going to point here like this. And then I'm calling the extender function with a list and num as parameters. And we know the way things work now, so we're going to make an extender namespace. And within it, we will define something like this. We'll make a box and we'll say, okay, well, we know that positional arguments are a thing. So my list, when it jumps to line 1 from line 6, my list currently contains, is going to point to whatever a list was pointing to. So I'm going to say my list is going to point to whatever a list was pointing to because it was passed as parameter. And then the variable v is going to point to whatever the num value was. And just to add a little bit of more functionality here, I'm also going to do v equals 10 here, just for the sake of it. Okay. So now, after line 1, I will come to line 2, and now it says mylist.append v. Okay. This is you changing the list here, changing whatever this is pointing to. And if this were a immutable object here, I will have to redefine it. Right? I'll do something along the lines of, oh, you know, I'm gonna make a new list. It's gonna be 1, 2, 3, and 4 appended to the very end of it. It's gonna look like this, and this sort of arrow goes away. But because lists are mutable, Python assumes that you want to change the original list, which means that what it will do, let me rewrite this. What it will do is it will modify the original list. So whatever a list was pointing to also gets modified, and this has some ramifications. Okay, so for now, just assume that whatever my list was pointing to, it's not going to redefine, it's not going to store a new list in memory and point to that. Because this is mutable, it's going to just add on to it. Okay, and then you're saying v equals 10, and v being an integer 4 is immutable, so it is in fact going to redefine it. It is going to say this, and basically this arrow sort of goes away, right? We know that. All good. Okay, now I am at the very end of my function definition. There is no return value. I'm not storing this anywhere. And so when I get out of this function and I finish executing this line 6, the extender namespace goes away. I mean, that is pretty trivial. It only gets defined when I'm calling a function, but now I'm no longer doing that. So everything it pointed to goes away too. And so all the arrows goes away. And if there is nothing being pointed to from the namespace also gets disappeared. So I can't really, the idea is that the number, the variable 10 is still going to be in memory somewhere, but you just don't know where it is. So think of it as just lost. And then you get this at the very end. So now after executing line 6, I come to line 7 and I print a list. It is now going to do 1, 2, 3, 4. So you have to be very, very careful in how you're basically using lists with parameter passing. Again, parameter passing. So you have to be really, really awfully careful about how you're using parameter passing with mutable objects. So sets, lists, they're going to be problematic. If you forget that you're modifying them and you assume that the modification will sort of go away as the function stops executing, but that's not going to be the case. You'll notice that I never explicitly said alist.extend or append 4, but it actually did that because lists, again, are mutable, and that's sort of what Python assumes you want to do. So what we're going to do in class is we're going to look at one more diagram of these namespaces and scope again, but now with multiple functions, and I think that will give you a nice idea of how things are working.